Hey there! Today we're going to learn how to run a logistic regression with odds ratio reporting in R. And the first thing I want you to do before we do that even is to install the Broom package if you haven't already done so. It'll come in handy later. I already have it, so I'm not going to install it here. Now, of course, we cannot do any analysis without data. So let's load our data, actually, and also show you what the motivation could be for running a logistic regression in the first place and why would we want an odds ratio. Well, I've actually drawn upon the US arrests data set, which comes pre-built in R. I changed the name of that to murder. And because this data set did not have a binary outcome, it didn't have an outcome that was coded as 0 and 1. I actually went ahead and created one and added it to the data set. And let me tell you what it is and what my hypothesis is. I use this syntax to label any state that has a murder rate out of 100,000 people as being a high murder state, and any state that is 10 or under in terms of the murder rate is a non-high murder rate state, just in my hypothesis. And I created that and added it on here as a binary variable. So for example, if we look at Alabama, it's 13.2, that's clearly over 10, so that would be a high murder state. Alaska at 10 would be a non-high murder state, and just sort of so on. Now, I'm going to show you the command to run a logistic regression, and then I'm going to show you how to use the Broom library to actually make that a lot more easily interpretable. But the first thing we need to do is we need to go ahead and just name this outcome, name this model, which I'm going to call it logfit murder. And I'm going to do the outcome of murder here, high murder state versus non-high murder state, right? My binary outcome as a function of urban population. So what's my hypothesis again? It's if urban population goes up, then the chances of a state being a high murder state also go up. That's my hypothesis. I specify the data frame, and I say family binomial because logistic is a binomial, a part of the binomial family. And now I have an outcome that I actually don't want to look at just yet. I want to pull up the Broom library, and I want to use this command here, which is very, very important, which you can replicate, and just say exponentiate equals true, because this is what gives me my actual odds ratio. You're going to see it in a second. So the odds ratio is over here for urban population, and it comes with a p-value, which, as we can see, is not statistically significant. Well, what does that mean? Interpreting odds ratios can be a little bit difficult. However, if you keep in mind that your coding can show you, which direction you're going in, it can be easy to interpret. Now here we said that a high murder state is coded as 1, and a non-high murder state is coded as 0. Now, if the OR, the odds ratio for urban population, is greater than 1, and it is statistically significant, that would tell us that any increase in the urban population would increase the odds of a state being a high murder state. And that's because we coded high as 1 and non-high as 0. If the odds ratio for urban was below 1 and it was also statistically significant, we would reach the opposite conclusion, that any increase in urban population would decrease the odds of a state being a high murder state. So let's work with a couple of examples. Let's say that these are examples for odds ratios, and they're both significant, let's say. All right, how do we interpret it? Well, if the odds ratio of urban had been 1.08 and significant, then we would just subtract 1 here, and we would say for every 1% increase in a state's urban population, there would be a corresponding 8% increase in the likelihood of that state being a high murder state. And correspondingly here, we would say that if the odds ratio of urban were 0.95 and significant, that every 1% increase in the urban population of a state would actually result in a 5% decrease in the likelihood of that state being a high murder state. As you can see, this interpretation depends completely on how you code your outcome. So if I had actually said I'm interested in the odds of a state being a non-high murder state, then this directionality would get reversed, for example, right? So I would say, for example, if my outcome is a non-high murder state, if that outcome is 1 and a high murder state is 0, and I could do that because, let's say, as a researcher, I'm interested in what makes a state a non-high murder rate state, then that just changes the interpretation correspondingly. So that if my OR were 1.08, that means that there would be an 8% decrease in the likelihood of a state being a non-high murder state. That's a mouthful, and as you can see, you can certainly get into like little logical puzzles, like figuring out how to like word this stuff. But I just wanted to point out that if you have a sort of meaningful coding system that is easy to interpret in the real world, then you won't have that problem. So if I were doing this analysis, I would just make sure that my data were set up this way, so that a high murder state is 1 and a non-high murder state is 0, because that just makes the OR like pretty easy to interpret.